Hi everyone, today we're going to talk about how to solve radical equations and inequalities. So our last set of notes we talked about transformations, and that was more based on a graph, so based on a picture. Can you transform the square root parent function left, right, up, down? Can you reflect it over the x-axis? And a new one was, can you reflect it over the y-axis? And then can you vertically stretch or compress or horizontally stretch and compress? And what does it look like whenever we do that in the equations? And so that was the last bit of square root notes that we had. And today we're going to talk about, if you're given an equation, how in the world do you solve it? Or if you're given an inequality, how do you solve it, and how is it different than solving an equation? So we've got a couple things to remember at the top of our notes today. We start out with something very basic, so the square root of x times the square root of x. Well, the square root of x times the square root of x means that you square root x, but then you square that. And remember that squaring and square rooting are inverses of each other, so those would cancel out, and you would be left with x. Also remember that if you have a binomial squared, then you can use FOIL or the box method to get a polynomial for your answer. So if I were to have written x plus 1 times x plus 1, x times x is x squared. X times 1 is x. 1 times x is another x, so that's 2x. And then 1 times 1 is 1. Again, remember that squaring and square rooting are inverses of each other, so the square root of x plus 3 squared is just x plus 3. And then finally we have something that looks really close to this. Same idea. If you have a binomial that's being squared, you would write it out 2 times, and you would do FOIL. And the last one I just kind of did it in my mind, but with this it looks a little different, so I'm going to do it on paper. So square root of 7 times square root of 7 is just 7. Square root of 7 times x is square root of 7x, and then I have another one, x times the square root of 7. So that's plus 2x's times the square root of 7. And then x times x is x squared. Now, before we move on, there are a couple things that we need to remember about the structure of a square root. And so we've discussed this before, but it's been a while since we've officially talked about it. So in our problems, we're going to have this, which is a radical. Sometimes it'll be the square root, sometimes it'll be the cubed root or the fourth root. So you'll have a radical, and then whatever is underneath, this is the word I really want to make sure you understand before we start today. This is the radicand. Everything underneath the radical is called the radicand. So when we talk about the radicand, we're talking about the stuff underneath the radical. For example, in number 3, what would be the radicand here? Well, it would be x plus 3, because that's what's underneath the radical. So our process to solve today is that first, we need to isolate the radical in our equations. We need to get it by itself on one side of the equal sign. And if there are 2 radicals, then rather than isolating the radical, if there are 2 radicals, then they're going to have to be on opposite sides of the equal sign. One on the left side, one on the right side. Next step is going to be to square both sides of the equation. Because if I'm square rooting, the only way to unsquare root something is to square it. And our last step is going to be to solve and check for extraneous solutions. So values that seem like they would be a solution, but whenever you substitute them back in, it turns out that they're no good. So we want to check for those and make sure we don't include those in our final answers. So I'm going to move this up. I'm going to keep my instructions there. First step is to isolate the radical, or if there are 2 radicals, put them on opposite sides. So here's my radical. There's nothing else on this side of the equal sign except for the radical and the radicand. There's no plus 7, there's no divided by 5, there's nothing like that. So this is isolated. This is the way that we need it to be. Now the next step is to square both sides of the equation. So I'm going to square the left side, square the right side. And what happens when you square a square root? Remember that they cancel out. So we're left with the radicand, 2x plus 3 equals, and 5 squared is 25. And then the final step is to solve. So we're going to solve for x by moving the constant. We now have 2x equals 22, and if I divide both sides by 2, I get x equals 11. So this is my answer, but now I need to make sure that it actually works, so I need to check it. And in order to check, I'm just going to substitute 11 in place of x. So we have the square root of 2 times x, which is 11, plus 3, and that should equal 5. I don't know if it does, but it should. So PEMDAS tells me under the radical, I do that first, and I do the multiplication. 2 times 11 is 22. 22 plus 3 is 25, and the square root of 25 is 5. This works. So that means that my answer, or my set of answers, because it's possible I might have more than one, my set of answers is just 11. All right, so let's look at number 2. First thing I need to do is isolate the radical. And I'll tell you why I need to isolate the radical. The second step, because there's not 2 radicals here, but the second step is to square both sides. And if I square this side, I'd have to square x plus the square root of x minus 1. And if I square that, I can't eliminate this radical. I can only eliminate the radical if I square the radical by itself. So this guy right here, he needs to move to the other side of the equation. That needs to get out of the way. So 3 minus x equals the square root of x minus 1. Now, I want to unsquare root this side by squaring. And the left side, the whole left side, I also need to square. So this comes up whenever you have a left side that has, or a right side, an unsquare rooted side that has multiple terms, you need to square the whole thing. So it's going to end up being FOIL on the left side. So if I do this, I'm left with the radicand on the right, because squaring a square root cancels out those operations. And then if I FOIL, 3 times 3 is 9. 3 times negative x is negative 3, but I'll have 2 of them because I'll have negative x times 3. So that's negative 6x. And then negative x times negative x is plus x squared. And then the final step would be to solve. Now this is a quadratic, so I notice that it's got this squared right here. That means that in order to solve a quadratic, I need everything on the one side, and I need the quadratic to equal 0. I need ax squared plus bx plus c. So I'm going to reorganize this, and I'm going to move these two things over here. So I'm going to subtract x and subtract x. And I'm going to add 1 and add 1. I'll have equals 0. My first term should be the x squared term. Then I should have my x term, so negative 6x minus 1 more x is negative 7x. And 9 plus 1 is 10. So in order to solve something like this, I'd factor. My magic numbers need to multiply to be 10 and add to be negative 7. Well, 5 and 2 multiply to be 10 and add to be 7, but I need them to be negative, so I'm going to make them all negative. So x minus 5 and x minus 2, those are my factors. So my solutions are x equals 5 and x equals 2. All right, so we got to make sure that they're both solutions, so I'm going to check. And the check part is easy. I just need to substitute my values back into the equation for x. So we'll do x equals 5 first. If x equals 5, then I'll have 3 equals 5 plus the square root, 5 minus 1. Well, the square root of 5 minus 1 is really the square root of 4, and that's 2. And I noticed that 5 plus 2 is not 3. So was this right? No. So that means that 5 is not a solution. But now I need to check the other one. 5 is extraneous. Let's check 2. So I have 3 equals 2 plus the square root of 2 minus 1. Well, 2 minus 1 is 1, and the square root of 1 is 1. So 3 equals 2 plus 1. Was that true? Yeah, 3 equals 3. So my solution here is not 5 and 2, it's just 2. 5 was extraneous. When I substituted that value in, it didn't work. Okay, so this next page has some problems that have various different things going on with them. They're not as basic as the first two examples that we had. However, I think that you could probably do them with a little bit of practice. So in number 3, I noticed that the radical is already isolated, but I noticed that the radical is a cubed root instead of a square root. And so that means that my next step of squaring both sides is not going to do anything. What's going to get rid of a cube root? Not squaring, but cubing. So if you cube a cube root, you're just left with the radicand, 5m plus 2. And then if you cube 3, 3 times 3 is 9, and 9 times another 3 is 27. Your final step. All right, so let's see if we can finish solving this. I want to isolate the m, so I'm going to subtract 2. 5m equals 27 minus 2, which is 25. And then dividing by 5 gives me an m value of 5. Why don't you go ahead and pause your video and check this on your own. All right, so we checked, and 5 works, so 5 is the answer. All right, let's look at number 4. Number 4 is our first problem that has 2 radicals in it. We've got the square root of x minus 7, and then we've got the square root of x right here. So our notes at the top say we need to isolate the radical, but if there are 2 radicals in the equation, they've got to be on opposite sides of the equal sign. So I'm going to go ahead and move, because this is a negative square root of x minus square root of x, I'm going to move this over because I'd really like for it to be positive. So I'm going to move this. And then I tell you what, I'm going to go ahead and move this too. And the reason why is because this radicand has more in it and it's more complicated than this radicand. And so I'd really like to get the x minus 7 out of this radical rather than just getting the x out of this radical. So I have the square root of x minus 7 equals the square root of x and then minus 7. Next step is to square both sides so that we can eliminate a radical. So if I square the square root, I get x minus 7. If I square this side, this is a little different. So the square of the square root of x minus 7, well, the square root of x times the square root of x is x. The square root of x times negative 7 is negative 7x, but I'll have 2 of them, so minus 14x. And then negative 7 times negative 7 is plus 49. When I missed this. Perhaps you were trying to tell me, and I just couldn't hear you. All right, so now we have something that looks a little bit more manageable. It looks kind of ugly because it's got a lot going on in it. However, I feel like we could definitely get this taken care of. I noticed that there's an x here and an x here, so if I do start to solve and try to get the x's together, these are both going to go away, right? So we'll have negative 7 equals negative 14 square roots of x plus 49, which is kind of nice because then there's only one variable. But now I'm back to my first step again, which is to isolate the radical, because I don't want the square root of x, I just want x. So I'm going to try and isolate the radical again, go back to my first step out of my 4 so that I can solve for x. So I'm going to move this 49. This is minus 56. And then I'm going to divide by negative 14. I'll have square root of x equals negative 56 divided by negative 14 is, what is that, 4? All right, now I have my square root isolated. I'm going to square both sides. I'm going to have x equals 4 squared, which is 16. And that looks good. So let's go ahead and check this. If I substitute 16 in place of x, I'd have the square root of 16 minus 7 minus the square root of 16 plus 7, and it needs to equal 0. So the square root of 16 minus 7, 16 minus 7 is 9, the square root of 9 is 3, minus the square root of 16, which would be minus 4, plus 7 equals 0. 3 minus 4 is negative 1. Negative 1 plus 7 is 6. 6 does not equal 0. So that means that 16 was extraneous, which means there's no other solution. So what is my answer? No solution. This problem has no solution that will satisfy it. All right. So let's try out number 5. I'm going to move this up a little bit so we've got some space to work. There are 2 radicals, so I can't really isolate the radical. I need to make sure that there's one on each side, and there is, so this is looking good. Next step is to square, so I'm going to square both sides. That will get rid of the radical here, and I'll have x plus 1. And if I square 5, then I get 25. If I square the square root of negative 1, or sorry, the square root of x minus 1, then I get x minus 1. Oh, this looks great. What do you do when you have a number out in front of parentheses? You distribute. So I have x plus 1 equals 25x minus 25. And I'm going to ask you to pause your video, finish solving, and check. So finish solving and check. Pause your video. So I have a feeling that whenever you got your answer, you either thought you were wrong, didn't know what to do, and started the video back, or you tried to start checking and you didn't know what to do, so you started the video back. And if you made it all the way through the checking step, then kudos to you guys, but I'm going to show you how to check this. So the x value that you get is 26 over 24, and if you divide both numerator and denominator by 2, you get 13/12. So if you put 13/12 in here for x, and you add 1 to it, well, the only way you can add to 13/12 is if you add something that has a denominator of 12. So think about how you can rewrite the number 1 so that it has a denominator of 12. Well, 12 divided by 12 is 1, so you just put the same number on top and bottom. And I do that here for plus 1, and I do that here for minus 1 as well. So once I have those numbers in place, I want to add. So underneath the radical, 13 plus 12 is 25/12. And then again underneath the radical, 13 minus 12 is 1/12. And what I get when I do this, and we talked about this when we simplified radicals, is you square root the 25 and you square root the 12. Well, the square root of 25, maybe I should start working over here. The square root of 25 over the square root of 12 is equal to 5 times the square root of 1 over the square root of 12. See how I gave the numerator and denominator the square root? So the square root of 25 is 5. And the square root of 1 is 1. Oops. And I just did that so it didn't look like 5 to the power of 1. But 5 times 1 square roots of 1 over the square root of 12, 5 times 1 is 5. So I end up with this. And no matter what it looks like, it is the same on both sides. So that works. And that means that my answer is the fraction 13/12. Okay. So let's look at number 6. Number 6, again, there's no way to isolate the radical. So there's two radicals. They are on opposite sides of each other. That's exactly what I want. So I'm going to go ahead and square both sides. Square this. Square this. Square root goes away. X plus 1 equals. Well, this is awkward. So let's do this out to the side. Maybe up here. All right. The square root of x plus 6 times the square root of x plus 6 is just x plus 6. We'll have square root of x plus 6 minus 1, but we've got 2 of them. So we're going to subtract 2 square roots of x plus 6. And then negative 1 times negative 1 is plus 1. So if I put these together, I'll have x, I'll have plus 7, and then minus 2 square roots of x plus 6. Now, if I try to combine these x's, then I notice that they go away. So I have 1 equals 7 minus 2 square roots of x plus 6. I want to try and isolate the square root again. So when I do that, I'm going to subtract my constant. And I'm going to divide by negative 2. 3 equals the square root of x plus 6. And I'm going to square both sides. I get 9 equals x plus 6. And when I subtract 6 from both sides, I get x equals 3. So now I've got to check this. And I know I've run out of space, but let's see what we get. So if I substitute 3 in place of x, the square root of 3 plus 1 is hopefully equal to the square root of 3 plus 6 minus 1. The square root of 3 plus 1 is the square root of 4, that's 2. The square root of 3 plus 6 is the square root of 9, that's 3. And if I subtract 1, I do get the right answer. So my answer here is 3. All right. So our last bit of work today comes from a reasonable domain. So notice that these are a little bit different because these problems are all inequalities, which means that our answer is not going to be one number. Our answer is going to be like all the x values that are less than or equal to 6 or something like that. They're going to be all the x values that are less than or equal to or greater than or equal to something. So when I solve in a similar way. My radical is isolated, so I don't have to deal with that. I'm going to square both sides. When I do that, I get the radicand 2x plus 4 is less than or equal to 16. I want to solve for x, so I move the constant. This is all the same thing. Everything so far is exactly the same. Divide by 2. X is less than or equal to 6. And we have an answer. But the last thing that we need to check is not so much if I take 6 and plug it in, does it work? The thing that we need to check is that this x is less than or equal to 6 falls into a reasonable domain. And we haven't discussed that yet. So a reasonable domain check. A reasonable domain check means that you've got to check and make sure that this falls within the positive values for the radicand. So the way you check this is you take the radicand, 2x plus 4, and you need it to be positive. So you need it to be greater than or equal to 0. So let's go see what all the x values are that are greater than or equal to 0. because remember your radicand has to be positive. You can't square root a negative, otherwise you end up with complex or imaginary numbers. So all my x values that are less than or equal to 6 are my solutions, but only if they are greater than or equal to -2, which is kind of hard to determine what it looks like. So I'm going to graph my reasonable domain and my solution set. So all of my x's less than or equal to 6, that's this way. All of my x's greater than or equal to -2, that's this way. So all of my solutions are the numbers that are from -2 to 6 and in between. These are my overlapping answers, so these are my solutions. So this is what I would write for my answer. So you've got to check and make sure that not only do you have your solutions, but you only include the solutions that are inside the reasonable domain. So let's try the next one. Square roots are already isolated, so I'm going to go ahead and square both sides. When I do that, I get x plus 7 is greater than or equal to 2x minus 1. I'm going to start solving, so I'm going to subtract x from both sides. 7 is greater than or equal to x minus 1. Add 1 to both sides. And I'm going to write this, but then I'm going to kind of move it around. So I'm going to move the x here, I'm going to move the 8 here, and I'm going to switch the way the sign is because I still need it to point to the x and open to the 8. So now I check my reasonable domain. Reasonable domain. So I have to check both of these radicands. I need x plus 7 to be greater than or equal to 0. So x has to be greater than or equal to -7. And then I also have to check that 2x minus 1 is greater than or equal to 0. So 2x is greater than or equal to 1, and x is greater than or equal to 1/2. So if I plot all of these, I need a -7, I need a 1/2, I need an 8. So my x's that are less than or equal to 8, that's my solutions. My reasonable domain is all the x's greater than or equal to -7, and all the x's greater than or equal to 1/2. So the overlapping area is all right here. It's all the x's from 1/2 to 8. So 1/2 less than or equal to x less than or equal to 8. And we write our compound inequality for our solution.